Okay, we're going to be looking now at, first of all, how to write numbers and letters, and you'll notice a difference between these two. For example, here I've got the letter Z and the number 2. Well, what's the difference between them? Well, one is 2, the other is Z, but I'll give you a bit of a hint. Compare these two logos. Okay, this is Lufthansa, this is for the French state. What's the difference between them? Well, you'll notice something. There's a little tail at the bottom here of the letters, which doesn't appear on Lufthansa. This is referred to as serif in English and French. So this is serif, this is sans serif. They refer to different, some people would say font, but in actual fact it's the typeface. I'm going to come back to why the German one looks this way. There's a history to it. I want to compare now two different typefaces, Arial and Consolis, particularly for numbers. Look at this one here. This is the digit 0. This is the letter O. It's not really clear which is which. Compare that with Consolis, one commonly used in computer programming. This is 0 now with a line through it, and here the letter O is very different. How about this? Consider the letter I. This is a capital I compared with a 1. Here it's more clear that this is a capital I, whereas this is the digit 1 as well. The difference between number 2 and letter Z, this is Palatino. It's a typeface. I keep saying font, but it's a typeface with a serif, whereas Universe is a famous font typeface which is sans serif. Here I've got the distinction. Typeface refers to the style or the name, Palatino times Roman. You may have heard of Arial. I've got Consolis, Helvetica, Universe. Font refers to the specific style, the size, whether it's italic, whether it's bold, and so on. The issue here is clarity. And let's take a look at this a little bit further. The history stake. Prior to the First World War, most things in German were written with a typeface that was known as Fraktur. There were variations on it, and you can see the style. One of the consequences of the First World War is that in Germany they switched to a font or a typeface which is clearer, easier to read, and typically sans serif. If you travel in Europe today, you'll see most of the road signs, many of the signs of cities and towns in Germany will be written with sans serif, whereas in France, still today, they're often written with serif. It's a question of style. I want to spend a bit of time on how to write numbers, particularly so that they're clear. I often write I'm going to change it to black. I often write the 7 like this. I cross it. One of the reasons for this is that, again, some people write their 1s like this, and it's not clear if that's a 7. So to make this absolutely clear, I typically write my 1s like this, and I write my 7s like this. And I cross them over. If you get in the habit of doing this, you'll avoid a lot of confusion. Nobody will ever confuse this for a 1. Another thing that I've always started, I did a long time ago and I still do now, this is the number 2, and I write my Z's like this. So it makes it absolutely clear, because if you write a Z like this, then people might think it's a 2. They look very similar, but in this case, it's very clear that it's not. Whatever typeface or font that you choose, try to make it clear. But if you get in the habit of writing your Z's this way and your 2's this way and your 7's with a line through them and a 1 with just a straight line, generally anybody reading your numbers or so on won't be confused by it. And this will avoid many errors that you may make in the future. You'll still be writing numbers and digits and so on. Rounding. I think everybody knows that anytime it's, for example, 5.693, the 3 will turn this, it doesn't change anything, but the 9 will turn the 6 into a 7, so this becomes 5.7. The 6 changes the 2. Here if I take a look at this number here, if I change this 6, we'll change it to a 3. But that doesn't do anything, so it remains at 5.3. If this 6 changes the 2 to a 3, but that doesn't change anything, so it remains at 5.5. Make sure that you understand how to do this very clearly. The basic rule is 4 and less goes down, 5 and more goes up. You keep moving from right to left until the number of digits that you need to have are recorded. So for example, if I take a calculator and write out 326 times 5,291, you wind up with this long number. If I wanted to round this to two significant digits, I would say 6, change it to a 7, changes it to a 9, changes it to a 5, changes it to a 3, but then the 3 drops out, so you're left with 1,700,000. As you've learned with Moodle, Moodle wants it to be written the English way, but generally Moodle doesn't like commas, so I would drop the commas, don't have them. Take that out, but of course you're going to have to put in a decimal place for the dots. When I say the French way, this is actually the way it's done generally around the world, except in the Commonwealth and British, remember Anglo-Saxon countries where it's typically done the English way. The Moodle installation we have is using the English method. Make sure you're careful with this, but in general you should cautious however you've written it. Notice where the dollar sign goes to. In the French way, the dollar sign is after the number, whereas in English it's before. Percentage and decimal places, these two numbers here mean exactly the same thing. So for example, if I write 0.271, that's the same as 27.1%. Just remember the percentage number is bigger. Sometimes you learn how to multiply by 100, but your calculator often will give you this number. In Moodle in general, I try to accept both, but sometimes it will only accept one or the other, then it'll be clear which one is required. The small numbers are generally correct, but big numbers become a bit complex. 3.453 is the same as 345%. And very small numbers also can be confusing. 0.0056 is the same as 0.56%. Just remember the percentage one is the bigger one, or if you have just a decimal, you can multiply by 100. Now, significant digits versus decimal places. Students often ask about this. If we look at decimal places, we're looking at the spaces after the decimal place. So for example, here there are 2 significant decimal places. On the other hand, if I only want to look at significant digits, then I would say it's 1, 2. Rounded to 2 significant digits, 0 is not a significant digit. Let's take another example. For example, if I have $373,000, if I want to round it to 3 significant digits, then I would just have the 3 numbers here. 5 changes to a 4, changes it to a 5, changes this to a 3. I can ignore that. But if I've got 3 significant, well, that should be 373,000. Oops, that's a mistake. I'll have to change that in the PowerPoint. We could round this to 373K if we want to, or they'd say in a Hollywood movie, the 1930s and 40s, they'd say 375 G's. K is the metric system. We'll look at that in a second. G's is the Hollywood. I don't know where that came from, but it represents 1,000 slang terms. This is the same one we had a moment ago, 326 times whatever. You wind up with this number. That would what the calculator would give us to 2 significant digits. Now we'd only have the 17, and the rest, we could write this as 1,700,000 or just 1.7 million. Means the same thing. Little point here to make is that you can't have more precision than the original data. If you kind of look at this here, I've got 4 digits here, I've got 3 digits here. Now it depends on what these numbers represent, but in a sense, if it's a series of data you're adding together, you've only got 4 significant digits here. So really, you can't claim that you've got precision to 7 digits when in fact you've only got 4 initially. So one of the reasons for reporting significant digits is the understanding that the numbers that appear after the significant digits are really not precise. I'll usually tell you whether I want to have the number of decimal places required or the number of significant digits to have in the data or the presentation. Memorize this. Hundreds, thousands, millions, billions, trillions. Let me repeat that again. Hundreds, thousands, millions, billions, trillions. Here you can see them written this way. This is the hundreds, the first before the comma. In the French system, it'll be a space. This is thousands. This is millions. This is billions. And this is trillions. What this means is you can see a very big number and immediately just go across hundreds, thousands, millions, billions, trillions. You know whether they're talking trillions or billions and whether it's significant. Famous American politician said a billion here, and pretty soon you're talking about real money. Everett Dirksen, was the guy who said that. In French, you've got les centaines, des milliers, millions, milliards, billions. This is confusing because this is the same and this is the same. In French, it might be better to refer to mille milliards because then the billion doesn't get confused with the English billions. In metric notation, you'll notice here's the K that we had just a moment ago. M stands for mega, G stands for giga. I think most people know this because you guys have gigahertz or you've got gigabytes. You're concerned about going over your limit for your phone in a month. Typically it's around 5 gigabytes, something like that. You probably know megabytes or megapixels because it's the number of millions of pixels in the precision or resolution of your camera. And then of course everybody knows kilometers and kilograms. So these are thousands. The example of the H is a hectare, which is the measure of space. I think it's 2.5 acres is 1 hectare. Tera, the only one you probably know about is a terabyte. That's huge in terms of memory space for a hard drive. And then above that is peta and exa. These are mammoth numbers. I just found this out of curiosity. I have no idea what petawatts are, petawatt hours, but apparently the world generation of electricity is about 24 peta. That's mammoth. And then I found Google. All of the data on their servers a couple of years ago was about 10 to 15 exabytes, which apparently that can't be right. About 10 million laptops. No, it's got to be more than that. Do you memorize this? No, you don't have to. But you should have as I said, most of you know what these letters are anyway, except for the big ones, the petas and the exas. There may be even ones after that, I don't know. Bits and bytes. Yeah, the typical phone plan in CAN has about 5 gigabytes. Little thing that's kind of interesting is that on the IBM keyboard, most keyboards today have about 64 different keys. And then it's possible to have, well, you can just have the key itself. Then you can press Shift the key, you can press Control the key, or you can press Alt the key. So that means to say there's 4 variations of 64, which gives us 256, and that represents 1 byte. In a byte, there's 8 bits. A bit is 0 or 1. So in effect, when we hear the word byte, you can just imagine it as 1 keystroke. I think the typical song, an MP3 song, is about 3 megabytes, so it's about 3 million keystrokes. The reason for its being much bigger is because the sound is a little bit more complex than a text. Text files are very short. We looked at this before. Hexadecimal, used for colors, it's about 16 million. That's kind of interesting is that the typical IP address, this is in effect your telephone number on the internet, has got 2 to the 8, which is, if I get this, that's 1 byte, 1 byte, 1 byte, 1 byte, so it's 4 bytes. This gives rise to about 4.3 billion different variations. We're running out of them. That means to say we don't have a sufficient number of IP addresses around the world, so they're switching to a new system that's called IP with 6, in which case there's going to be 4 times more, like to 16 bytes. There's a huge number. If you're curious to know what your IP address is, just go to Google and type in what is my IP version 6 address. I think most of the providers now in Canada are providing everybody with this. The idea is that we're going to need a lot more of these telephone numbers because every single device in effect will have its own IP address. I want to just finish with a little bit of fun here about numbers and how big things can be and how to understand whether it's possible to understand these things. We estimate that there's about 100 to 300 billion stars in a galaxy. Our galaxy is the Milky Way. Using telescopes, we've been able to estimate, we can see about roughly around 150 to 200 billion galaxies in the universe. These are ones we're aware of. So you just stop for a second. You've got about 150 billion stars in a galaxy. There's about 150, 200 billion galaxies in the universe. Multiply by one or the other, you got a mammoth number. Keep in mind, too, that we think that the universe is about 15 years old. Our sun is about 5 billion years. So that means to say, in history, given the time span, almost anything is possible. To put this in perspective, if you ever go north of Montreal late at night and it's clear sky, you can see with your naked eye. If you think of all those dots you're looking at, it's only 4,000. So there's something well beyond what you see. All those points of light is much, much faster. Something else to think about too is that within about 100 light years of Earth, there's about 1,000 stars that are of type G, similar to our own sun. Now, this is relevant because we've only been broadcasting radio signals for about 100, 120 years. So that means to say that the number of stars potentially that would be aware of us is only about 1,000 or so. And they would only be becoming aware of receiving a signal that's intelligible from us in that time. So the whole idea that we could possibly communicate with stars in other parts, it's just not there. The numbers aren't good enough.